Hello everyone and welcome back to a new exercise on LeetCode. Today I bring you number 200, number of islands. We have a grid of n columns and n rows, and this grid is filled with just ones representing the land and zeros representing the water. And we want to return the number of islands in this grid. An island basically is a collection of land that in all directions we have water. And we should assume that whenever we are out of bounds in our matrix, there's also going to be water there, okay? By just looking at this grid that we have here by 4x4, we can deduct that we have two islands. And which one will be this one? It will be the first one, and the second one will be this one. To do this, we should use an algorithm called DFS, depth first search. Basically, what we want to do is we want to parse the full grid. And every time we find some land, we are going to increment the count of the number of islands we found by 1. And then we are going inside our DFS function. And what does the DFS function does? Basically groups all the pieces of island, so all the ones, and it groups them together. Basically, we should like say, oh, we know that this is a piece of island. So which islands are connected to this piece of island? This one is connected, and this one is connected, and this one is connected. So we don't count these pieces of island anymore. And this like collection is one full island, okay? We are gonna like sort of like cheat a little bit. Like we don't need another extra data structure, like another grid. We're just going to change the islands that we see into water, so we don't count them anymore. So we see that the first element is a 1, so we are going to start our DFS. We change the 1 into water, and then we search for more land in all directions, okay? All right. And we see that the neighbor is also land. And we go down, it's also land. Then we go back in our loop, and we already check this element. We see that this one is water, this one is water, 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 water. And now we're back at 1. So we see that this one is land, and we increase the count to 2. Okay. And then we are going in our DFS function, and we change this one. We go in all other directions. Okay. And if it's out of bounds or it goes like to a 0, we are not going to do anything. Like we just exit the recursive function DFS. But if it's water, then if it's land in this case, then we change the land to 0, and we recursively call the DFS function because maybe there's like more pieces of land that are connected to this one. Okay. So for example, if this one is also a piece of land, okay, let's pretend that we didn't parse this already. We are going upwards. We're going to change this one to 0, but this one is not going to increase the count of our number of lands because this one is connected to this piece of land, okay? They are connected this way. Okay. And then because we parsed the full length and like height of our grid, so we are concluded with our algorithm, and the solution that we provide is going to be 2. Let's jump into LeetCode and see how we can code this in Java. Welcome on LeetCode. So let's start coding our solution. First of all, because we have DFS function is going to be called recursively, I am going to instantiate some variables at the beginning of our class. So like this, I don't have to pass them inside a parameter of our DFS function. And that will be our grid. So let's do a matrix of characters. I'm just going to call it matrix. And then we are going to have int row, which represents the rows of our matrix, or like the length. And then we have columns, okay? And then I'm just gonna create a static variable. So a static int called directions. That'll be a new int. This is also, it's not just an integer, is b-dimensional array. And now I'm just going to explain very quickly how we can use this. So this is an array that has every single direction we want to go in our DFS function. So basically what I'm going to do is I'm going to loop through this array, and every time we loop around it, we are just going to pick one direction, and we're going to call our DFS in that direction. Okay, so we're going to update the variables, and I'm going to show you how we can use this array to call our DFS function in all the other directions. So now that we are inside our method, we have to initialize our members. So let's start initializing our matrix. It's going to be equal to grid. And then the rows are going to be equal to the grid.length. And then the calls is going to be equal to grid of 0.length. Okay, and now we should also have like int_sol, like a whatever you want to call it, to 0. This is our counter. And I think I did everything. So now let's start creating our for loop. All right, so now we have the condition if, all right, just make sure you're using characters, because apparently it's a grid of characters and not a grid of integers if you're using Java or any other art type language. So if matrix ij 1, so what happens? We're going to increase our solution by 1 because we find the land. And then we are going to call our DFS function, and we're going to pass our coordinates. So let's just return solution here. And of course, we cannot run it yet because we need to create our DFS function. So public void DFS. Okay. So this function is just going to change every single piece of land into water. Like this, they are basically marked as visited, and if we don't hit any land, we have to just not do anything. First thing we have to do, we have to put the if statement. If we hit water or we go out of bounds, then we don't continue. Let's just do out of bounds first. So if, how do we check if it's out of bounds? So we have to make sure that I is less than 0. Okay, not greater, less than 0, or I is greater or equal to rows, or j is less than 0, or j is greater and equal to columns. Okay, and then if we hit water, so a matrix of I j is equal, and we use the character. And if this is true, we're just going to return because we don't want to continue, right? But if it's actually false, so we want to first change the value to 0. So because we got a 1, so we're going to do matrix of I j equal, and make sure that you use character. And then for each direction, so let's do int d or dir. Okay. Oh, this is gonna make common error because it's a static, so we have to do solution dot. Okay. And if this is the case, then we just have to call our DFS, and we have to do I plus d of 0, and then j plus d of 1. And I believe that's it. Let's try and run it and see what happens. And we got it right. Wow, amazing. Not sure if it's gonna be submitted. Let's try and submit it. Let's see if it's correct. Looks like it's correct. And we got a pretty good speed. All right, let's finish up. Let's talk about the complexity. All right, so let's analyze our time complexity. So we have our grid here. When we parse our grid, we have to parse every single element. And so that indicates that it's going to be big O of M times N, where like M is going to be the number of rows and N is going to be the number of columns. And if you think, oh, but there's like a DFS, like there's every time we are going to call a DFS function that is gonna be called recursively. But if you think about it, our DFS function will at most be called by the number of cells that we have. So basically we're just gonna put up ×2 here. But because we are in big O notation, we don't even consider this ×2. And so we have big O of M times N, and that's our time complexity. And to end the video, I just thank you to watch, and hopefully you can subscribe and like the video. I'll leave the full code here for just look at it. Thanks again and have a good day.